Welcome back to the bench. Today I'm looking at a MacBook Pro. Problem apparently will not hold a charge, will not even take a charge. I have no idea as to the runtime leading up to this, but will run off the charger, but won't run off the battery inside. So we'll do some basic tests and see what's going on. And this one's a MacBook Pro model A1502. Now the MacBooks in Apple tradition still use the pentalobe screws, much like the iPhone. The only thing is they're a lot larger, and if you have access to, maybe you've got a few kicking around from doing some screen replacements, there's your typical iPhone pentalobe screwdriver. But because they're larger, you can put that in there and turn it, and of course nothing will happen. So what you do is you take to it with a grinding wheel and end up with something like this. A much stumpier looking pentalobe screwdriver which fits the hole. You can see that they're tapered, so you can quite happily grind it back until you have a larger pentalobe shape, and you have no trouble undoing them. And you want a nice tight fit because they can be quite tight, I've noticed. I think they may have even used a little bit of thread locker on them. Now with all the screws out, I think the bottom should just lift off. It's lifting around the edges. Maybe some clips involved as well. I have had one apart before, so not entirely uncharted territory, only I just can't remember exactly what I did. So let's just try a spudger around the edge here. Oh. Yeah. I don't know if you can see that, but it's lifting along this edge here. It feels like it's getting stuck there. And if I lift the left side and come down the left side, it's definitely lifting. Something in the middle is holding it. Now I wonder if it's sticky tape or something else. It's probably tape, knowing Apple. Let's give it a gentle pry and see if we can peek in the back and see what's holding it. And with a little more leverage up the back, away it comes. And can we see what was holding it? Because it was fairly well held down. Nothing obvious other than liquid damage. Get a load of this. This is liquid stains, and I would bet your bottom dollar here's these little spots here are rubber, and as the liquid dried, looks like a sugary drink, they've probably just stuck it down. So normally this would not be stuck down. Oh dear, oh dear, oh dear, not a good start. Okay, so what are we looking at? Well, here's a non-expert's point of view. Fan, heatsink, and CPU, just by deduction. Yeah, anyway, wireless card. We have the aerial cables going in. This will be RAM. Here we have an SSD. Battery packs, all to give it its nice long run time. Inductors. These are large square grey packages, and that one, and that little one, and that little one. Some nice large capacitors. So this is our, obviously under here we've got our connector for the batteries. So this is our supply rail and battery charging systems, and where our attention's going to be focused for most of the point. We're going to have to look at the top side, because usually liquid ingress will come in through the keyboard and sit on top of the board. There's usually not a lot to see on the underside, as is the case here, other than where it's pulled there and on there, and there's a stain around here which is a cover over the battery connector, which has possible residue having pooled under there as well. Let's take a closer look in that area. And lifting that piece of tape, we can clearly see green corrosion all around here. Now, I don't think this is leftover liquid. There's a glue that's been put down over these components. Maybe it's been done to try and help waterproof the system, but obviously hasn't worked too well, because there's always going to be some exposed exposed metal conductors, and that's always going to be a problem. And the corrosion has eaten away at the end of this diode here. It's all turning white, and around here. In order to remove this board, we have Torx screws. Now this connector just lifts up, snaps down on there onto the motherboard. Not too sure what to expect under here, or how even attaches to, I believe the cable from the battery pack comes up into here, but I'm not 100% at this point in time. I think this is our keyboard connector, mousepad connector, and under here looks like speaker connector and something else, and I'm not too sure what that's joining to there, although actually, is that a separate board under there? I think there's two separate boards in here. There is, you got your main board over here, and this is a separate board, and that has your USB and whatnot, so it's like a separate I/O board here, and yeah. So let's have a careful pry under here. And it's got some double-sided tape. We'll go for a plastic tool. We don't want to be possibly shorting anything out. And just give it a little bit of a separation. I don't know what sort of plug they've used down the end there. It looks like it's all in one kind of thing. I wonder if that just pulls off. So it appears that the battery is actually soldered into the end of this board, so there's definitely no plug on there. It's looking like the entire lot with the black frame must be all part of the battery pack, so we'll need to separate that, and I think the majority of it's held down by double-sided tape under the batteries, which just makes things difficult. Right, so this connector here, that pulls straight out, and I strongly recommend getting some pliers either side of that to do that, much like that, and gently nudge it out. The wires don't seem to be held in there very strongly, so yeah, be careful with that. The next one over here, that lifts straight up, so you just need to get something underneath it and give it a little encouragement up. It's a little flat flex cable, and it looks like it's the sort where this back edge is a locking edge that folds down, so if we're very careful, that should just lift up. But I have been fooled before with these. Nope, that one flipped up. That was lucky. And same again with this one, only a much longer edge. This one's being larger and B being so close to the frame, it's not actually going to pull out, so I'll leave it loose, and we can slide the board out away from it. Initially they would have assembled that and then put the battery pack in and sandwiched that in there, but don't quite have that luxury yet, because I really don't want to start flexing these to get them off. They do feel like they're on pretty tight. I had a bit of a go at it. Little connector over by the fan, that also just pulls straight out. Again, I used pliers on either side, just lightly, but enough to stay in behind there's a couple little bumps that stick out each side, and just to pull it by that. And if we swing over here, we have up in the top corner the video cable for the screen, and as is common in laptops, they have this little round bar that sits along there, and it just flips down to lock it in. So we just need to lift that bar like that, and it just hinges up out the way, and then you'll find that the cable should pull out relatively freely, and you can usually just give a little bit of a tug on that bar in order to shift it, and it comes out nice and easily. Another large one down here. It appears to be just a plug straight in, so that should pull straight out. And down here looks like another one that lifts straight up. Okay, there's a couple of other small flex connectors, one down there and one over here that just plugs in, lifts up with a snap-in plug. This one down here slides in and has one of the little lift up locking edges on it. And then over here I've taken the fan out, and we have the motherboard relatively loose. The fan actually is in a metal shroud. It's all one piece that slips in under the heatsink, and this is just sticky back, sits down on the fan. That can just lift up and keep that out the way. I'm going to leave the heatsink attached. There's no sign of liquid in this area, and it means I don't have to re-thermal paste the CPU either. Now it looks like the whole board should now just lift up and out from this edge, but kind of that way to clear that flex connector there. So we'll just gently wiggle and so on. Oh, that's actually just slipped out there. So a little bit of encouragement, and just brushing off any leads that are getting tangled. Here we come. Give it a bit of a rotation to get away from those battery connector, and we're free. Alright, let's see what the damage is. Well, that looks surprisingly clean. Wouldn't hurt just to give the whole thing a wash down anyway. And certainly with all the charging circuit area there, it is all looking pretty clean through there. So I think the bulk of our problem is contained to the battery pack and the board that interfaces that to the motherboard. And I think, looking at the white powdery stuff at the end of this diode, there's almost every chance that the leg of that diode is actually being completely eaten away and is no longer making connections. So okay, so I thought pulling the batteries out may not be too much of a deal, but they are fairly well stuck down, and in the interest of not damaging them, I'm thinking I'm going to look for an alternative direction. Under here I've looked as carefully as I can. There doesn't seem to be any corrosion or whatnot on the underside. I think I'll steer away from looking at this, even though there was the corrosion on here, as being the source of the problem, and plug it in and actually see what is going on as far as the charging circuits and what have you. Hopefully it's not a intelligence thing and the pack is telling the system to not turn on. Here's a sticker, 11.3 volts should be the total output. At the moment it's down around 4. I guess there's every chance that it's sunk to a point that's not acceptable for the system, so it's not going to even attempt to charge it. It may have gone into hibernation, so to speak. I guess what I need to do then is possibly even manually charge this thing. Let's see if we can work out some of the pins on the connector. Now I've got the continuity on the meter there. We've got a beep when we get a connection, and we'll just see if we can figure out which pins are ground, and we can do that because we know that these are almost always ground. So I'll stick one lead on there where there's a screw post and an exposed copper, and we'll start at this end. Alright, so those 3 there are all ground, and I almost guarantee that the 3 over this side are going to be all positive. Now I wonder if we one of these caps is going to be an input cap, isn't it? Here we are. No, got to be some resistance there. I wonder if we can get a hit off any of the inductors. I can almost guarantee that the 3 on the other side are our positive, and the 3 in the middle are actually shorter connections, and you can see on here too that they've spaced them differently. So I've got a group of 3 negative, I guarantee you the group of 3 positive here. I looked at the underside of this board, and there's a FET switch, one of those sort of 6-pin devices, no, 8-pin devices that I showed you in the last laptop repair, where much like this, you've got a row down one side which are all connected, a row 3 of the other ones are all connected, and one is the on-off control or the gate, and they went to the 3 on this side. So well, the one under this board went to the 3 on this side, so that'll be our positive feed, whether that's the switch in or the switch out. Probably the switch in. Just having another probe around, I noticed some extremely fat wires come in here and here. I'm not too sure where this connects to, but if I connect between, well, here and here, we have a direct connection. So I'm going to say those are negative, and if I shove a lead on there, we've got 4.2 volts there. So I'm going to say that that's our input from our batteries. These wires that come in here are probably for temperature monitoring of each pack, balance charging, monitoring, whatever. So I've only got 4 volts. This pack in total should be 11.3. So I think the first step would be to manually feed some charge in and get this pack up to normal operating voltage, and cross fingers that none of the cells are damaged as a result of sitting in a state of serious discharge for I'm told a few months. Right, where was I? Okay, yeah, I attached a couple of wires here. I've just fed in some charge off my bench supply, current limited to 1 amp, and maximum of 12.5 volts. It was on for about an hour or so, a couple of hours almost, and I think it's probably sitting around 60 or 70%, probably about 70% charge. It should be enough to turn the thing on and run and so on. Now, taking a measurement with the 2 outside sets of leads, I've got negative and positive, and I've got nothing on there. If I connect the main board to charge, we have our negative, our positive, and we get 12.5 volts on here, which is being supplied by this inductor here, and I haven't traced it out yet, but I think it's going via this FET here. So I'm 100% sure just by looking at its location that it'll be going via that FET. Of course, when I connect the battery, that 12.5 volts drops to nothing. So the fact that we have 12.5 on there, and as we just calculated, 12.5 is the required voltage for maximum charge, obviously the motherboard charge circuit is working. Only when you connect the battery, something is telling it, hey, don't charge me, something's not right. Yet we're still getting nothing on the output. 2 volts. We know that this FET, its output connects directly to here. We know that we have 12 volts, well, sorry, 11 volts on there. It's not fully charged, but it's not coming through. For whatever reason, this isn't being turned on, and at least I don't think it's being turned on, though there is 2 volts on the gate. Whether it's enough to turn it on, I'm not 100%. I'd probably think it'd be 5 volts, wouldn't it? What have we got on this one? Because this one, well, this one's actually on, and this one has got 10 volts, which is passing through battery voltage. So that, I guess that has to be 10 volts. So I guess we need to figure out what's driving that. Okay, so I mentioned a look like an unstable voltage on one of the signaling pins of the battery pack, and I thought, what would that be? Because my multimeter can't see this. So obviously something is alive and well on this the battery management board. What we need to do, I think, plug it into the motherboard and see how that signal might change, and what shows up on the other ones. Although at the moment it means absolutely nothing. Maybe it's a heartbeat. Kind of looks like a heartbeat. Right, I'm about to plug it in. So I'll plug it in while watching this and just see what effect that has. Wow, that attenuated the signal quite a bit, but it's still there. Let's just check the other 2 signal lines. Still nothing, and still nothing, and of course we still have nothing on the output. I wonder if that should be attenuated so much. If I take it off again, we're getting just over 2, which is the same voltage I'm seeing on the output of the pack, which is probably all the voltage that this management circuit has to work with at the moment for whatever reason, which probably is only a stray voltage due to something not switching on properly, which is probably why it's getting pulled down so much when you plug it into the main board, because yeah, there's not really any current available. Interesting, eh? Okay, so here we can see there's 2 FETs on this board. This is the battery management board, and the positive output is being held up by this FET. It's not being turned on fully. So what I'm going to try and do is force it on and see what our signaling line looks like when I do that. So what I've done is I've attached this wire here to the gate of this FET. Now this one is turned on. We've got battery plus on this side, and it's coming through to this side, which is connected directly to here, and it goes through there and out to here. And what I'll do is I'll just this wire's on the gate, this is on. I'm going to use that to touch the gate on this one and turn that on, and see if we can get battery voltage through there and some kind of something else happening that's a bit more relevant. So I'll focus you on the scope, and we'll look at the signal rail. It was we've got the 3 negative, and then the 4th one along is the one that has our pulse that we saw before, and we'll see if that stays at 2 volts or drops off again or goes higher, and if that has any effect on the system. So before I connect it to the motherboard, I'm just going to try this. Now there's our output. It's sitting about 2 volts, and if I turn this on, that's on, and we're sitting at about, now that's our 11 volts coming through there. Well, we can plug it into the motherboard now and see what sort of effect that's going to have on things. Certainly not going to break anything as far as I can tell, because it's supposed to have full battery voltage on there. Whether we turn it on by hand like that or whether it turns itself on, I hardly think it's going to be an issue. Okay, we're at 2 volts per division now, just so we can get a clearer picture, and we can just barely see our attenuated signal there. And I'm going to connect the wire to the output, and we'll watch the output come up. And check our signal line again, and our signal line's still pretty low, but we'll check our other wires there. I've got data on there, and we've got some data happening on there. That's interesting. So now I'll take off that gate wire, and no, our output still drops off. I don't know what's going on there. We don't have any communication on those other 2 lines. Our little pulse train is still there. I wonder if I have to turn it on to actually achieve anything. Hit the power button. It's a bit tricky with it all folded up. I noticed when you plug the charger in with the battery connected, it pulsed the gate of the output FET on the management board, and I thought I would just see if that how that relates to the output at the plug. And as you can see, I've got 1 channel on the gate and 1 channel on the output, and they line up pretty good. So it's not like when the FET turns on, there's not enough coming out, so it decides there's a problem. That's coming up to, that's our full battery voltage at the peak, and it pulses it 2 times before it gives up. Right, so on realizing that I hadn't got a lot of charge into the cells, I left it on a bit longer and got it up to almost, well, for all intents and purposes, fully charged. Still no go. Well, after much searching and a little assistance, I found the schematic. This is a lifesaver when working on such things. Now I'll just quickly show you the area that I'm looking at. Here is the FET down in the bottom left that controls the charge or use of the battery power. It has an internal diode which goes from drain to source, and it's a P-type FET. Now this is the one that I identified earlier and removed, and I thought I had it right. I actually put an N-type FET in place because I had no idea really. I couldn't find a datasheet on it, so I popped a FET in. I thought it was working. It was actually an N-type FET which had the diode in the opposite direction, which meant that whether or not that was being switched on, we were going to get charge voltage coming straight through to the battery, and that's what we saw. We saw the 12.5 volts on the battery, so I thought, yeah, it's charging, but I was wrong. It wasn't charging. It was just, well, it was coincidental. So so that aside, I now have a P-type FET that I have removed from the same junk laptop that I pulled the previous FET from. It's the same package. and we'll see if that is going to work. And what happens is we've got the battery positive comes in on this line here. Now if it's in charge, then the charge current will flow through the FET from source to drain through to the battery. When the FET turns off, when you remove the charger and it needs to run on the battery charge will come back through the FET's internal diode and flow back through to the rest of the circuit, which follows this path along here, up here, back that way, and up to the fuse, which is a 12 amp fuse, and that is intact and off out to the rest of the system. So the rest of the system is either using charge voltage, charger power, or battery power. Over this side on the left we have two FETs in one package, which is something I haven't seen before, and that they oscillate. We've got up here frequency 400 kilohertz across this inductor here, and that creates our charge voltage, because I think from what I'm reading there's 18 volts coming in off the charger, and this converts it to 12 for the battery and system power. Now once it comes off either the charger or the battery, it comes in the top left here. We have two diodes. The top one has charger current coming in to power the system when on charge. The bottom diode, the battery connects through to power the system on battery, and this circuit here is used to regulate the 3.425 volts, which is known as G3 hot, and it seems to be common among Macs from what I've seen, and that is one of the main voltage rails that needs to be present for the system to run, and that comes out the right, that comes out up over here on the right out to the rest of the system. So I have had a look at the connection from the FET through to here, that FET that we replaced, and the battery, well, the FET does connect through to, there's a 10 ohm resistor here and through to this diode pack here. I've checked that and it does come through there, so almost guaranteed that replacing that FET with the proper P-type FET is going to resolve my problems. I'm really hoping, because I've still got no voltage at the battery terminals, but what I'm hoping is going to happen is when I connect it, the system is going to talk to the battery smarts and say, hey, yep, cool, you can switch on, I see that you're all right. Having a look at the back side of the motherboard, here's the battery connector, here's the FET that I've replaced, this is the 12 amp fuse that we were looking at, and down here, this is our 3.425 volt regulator circuit that we saw in the second screen, and over on the top side we have our charge connector comes in here, and that FET that we had on the bottom side comes through this little package here, is the two diodes. We've got the charge coming in here, and there's our 10 ohm resistor coming into the other diode, and out the top, which goes off to that 3 volt regulator on the back side. Down here in the middle of between these caps there is the dual FET package, which I actually removed because I wasn't sure what was going on there, and I had a feeling that's what it was, with a trace running off underneath it, and there's it's QFN, so no leads, but there's like cut-offs down each side where the extra connections could be made, although it seems to be made with the large exposed copper on the back, and I was able to measure through to those pins to the battery line, so I pulled it off anyway and had a look, and yeah, crossing fingers that it's all going to work. Now I've put it back together, reflowed it with a bit of solder paste under there. So enough talking, I guess. Let's plug it in and see what happens. So I've got scope is going to be connected to battery plus, and you can watch the output with me to see if the battery turns on when I connect it. Now we're going to go 2 volts per division. We're expecting it to go about here, 12 volts. So hopefully, and this is with no charger attached. At the moment we have 2 volts on the output, and we'll see if the system recognizes that and enables the battery. Here we go. And we have nothing on the output. Maybe we need to plug the charger in to get it to recognize. I've just increased it to 5 volts per division, and I'm going to attach the charger. And we'll see if the system begins to charge. We have green light, we have orange light, although keeping in mind that the battery is, no, the screen lit up and then it went off. It thinks the battery is fully charged, as the green light has come back on the connector. Oh, it looks like it's going to boot this time. Let's see what we've got going on this side of the inductor here. So there's our 12 volts there. Obviously the FET is not turned on, otherwise we would have our 12 volts on the battery, but we have nothing. And if I pull power off, still shuts down, because for whatever reason there is nothing coming out of the battery pack. It's being kept in an off state. So there's 1 volt per division, so we're at 2 volts coming out. And if I go up to the other end of that diode that I showed you with the 10 ohm resistor, we have battery voltage there. So I'm confident that if we can get the battery pack to actually output something, that this will actually work. I've found a datasheet for the battery management IC. It is a Texas Instruments BQ20Z45, and I can now check some pins on the chip to see if everything's kosher, and I found that it has supply voltage, it has 3.3 volts, there's another 2.5 volt one, there's reset lines which are not active, and a couple others, and the gate drive pins for the onboard FETs, which are suggesting one is for charge, one is for drain. So here's where the wires come in from the battery pack, and there's 2 rows of 3 there and there, and what we have is these 2 outer pins are ground, and these 2 pins have the exact same clock pulse that we saw on it's actually this line over here. Now I'm pretty sure this is a battery enable, or it's a battery detect line, so when it's plugged into the motherboard there's a 10k to ground that pulls that signal down. These pins have exactly the same signal, but at a reduced voltage by comparison to here, but it's exactly the same. And then we have our sense pins of 8.4 and 4.2 volts. The 12 volt here goes directly to the chip, the other 2 pins that were 12. So there's 4 pins, 2 go to 12 and 2 go to these 2 here via a 100 ohm resistor. They're all via 100 ohms to the chip. Okay guys, this is what I've done at the moment. I've hooked the logic analyzer up to the SM data bus on the battery. There's a clock line and a data line. You've got the clock line at the top of the screen there and the data at the bottom. And I just thought, well, I'd just see if I can figure out what the motherboard is requesting, because the SMBus is a standard. There's heaps you can read about that. There's lots of documents out there on what is what. And so being a standard, I thought there might be a chance I could see what information it's requesting and what that information contains, to see if the battery is saying, hey, don't use me, I'm no good. So there's a whole lot that happens, and this has been left running during the boot up of the thing on power on the charger. And just to give you an example, here is a normal looking setup for reading data. We have it's requesting now I believe I've got it all showing in hexadecimal at the moment. The if we have a quick look here, we've got all these hex values which are addresses for different areas. So if you want to know temperature range, you address 72 hex. If you want lifetime data, it's 73. If you want average voltage, it's 5D. So that's how that works, and you just feed that address onto the data bus, and then it comes back with acknowledgement. So now I'm pretty sure it's 16. I don't quite get this first section. I'm pretty sure it's a device identifier, although I have found an Arduino sketch that also communicates with these, and it puts in 22. Hang on, if we have a look in yeah, okay, 16 hex, it comes up as 22 binary. Anyway, hang on, don't want binary, I want hex. So it addresses it flags the device it wants to talk to. It sends out the address it wants to talk to. In this case is 00, and then the battery comes back with read. It's got its device ID on there and an acknowledgement, and then you get your data out. So that's all fine and dandy. Don't ask me what 00 is. If I have a look at the document, this is the data sheet for the Texas Instruments BQ20Z45 chip, which is on this particular pack. It has all of the addressing standards there. So if we go to 00, it's got a manufacturer access. That could be anyone's guess what data's stored in there. But anyway, so that's all looking fine, and we cruise along here, and there's a period of no activity here. Then we have 1 to A6, and A6 is anyone's guess. It stops at 7F. So I don't know, is that corrupt data? Is that valid? Is that some special hidden thing that's Apple only? Is there something else on that SMBus line, and it might not even be talking to the battery? Who knows? And then we come along, and then there's another one, and you can see here we go again. We've got the clock, and then the clock is nice and happy, and then it's about to set up again, and the clock stops. And the data that it spat out was device 12. La 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 la. Oh no, the clock, there's a glitch in the clock there, there's another glitch. We're coming back with 0 in the data stream and the clock is looking absolutely ridiculous. Now we zoom in on there, we've got a 3 megahertz there. If we go between these ones, that's running about 4 megahertz. If we try and find a much more, 6 megahertz. Our clock does not run at 6 megahertz, and you can see what's happened is the data is all but almost non-existent. If we go back to where it was somewhat good, here we go. The clock frequency is only 100 kilohertz between these. Now you can't see off screen, but it's calculating it for me as I put the mouse over it. And then we go out to here where nothing's working, and when we do get bits of clock, it's a megahertz. It's really screwed up, and I'm wondering if the clock line just starts having a fit and everything goes to hell. And look, we've got nothing in the data. We've got random packets of clock and 0 on the data line. It doesn't know what's going on. So it goes for on and on and on and on and on and on and on all the way through. So Okay, this is another pass. I did have a couple of resistors off that line for the going to the Arduino pull-up. Although the Arduino wasn't powered on, the resistors were still tied at the other end, although they are 10k as well. It shouldn't have affected the signal, but I've removed them for this pass. I don't know if it's had any effect yet, but it's just straight into the logic analyzer. Now we're looking at the clock signal up here is running still at 100 kilohertz. And the first in the list we have a write request to 16 hex, or address request of 16 hex, and 16 is battery status. And the result of the battery status is spit out. Now I'm not too sure what battery status values mean. Next one along, it's looking at 0F, and 0F is remaining capacity, and that is read out as, if we have a look at global settings, let's see what it says, 252, 20 and 155, which was not acknowledged. Here we go, 0F remaining capacity is expressed in either milliamp hour or at C/5 discharge rate, or as a power 10 milliwatt hour P/5 discharge rate, depending on the setting of the battery mode's capacity mode bit. There we go, makes sense? A bit further along here we've got 15, address 15, which is charge voltage, which is reported in millivolts, a value of 0 to 65534, an 8 and a 1. So I think charge voltage at that point in time is non-existent. It's 81 millivolts. So you get the gist of it anyway, value's valid or not, but having a look along here and seeing if it's going to turn into custard. 14, which is charge current, and it's reading back as 0 in binary. It's only going to be one little pulse there, so no, that's fine. No charge current, and we've got 0 again for the usage current, which makes absolute sense because it's not charging it, it's not running off it either, it's just being difficult. And then we go to 0.9, which is voltage. Let's see what it thinks the voltage is. That's interesting. And if we convert that back to decimal, even, and see what the spec says we should be reading voltage as, return cell pack voltage in millivolts, and is output as a real word. So voltage, and if I'm not mistaken, I could be completely wrong here, but I've got 18248, and if you divide that by 1000, because that's in millivolts, that's 18.248 volts, which I think 18 volts is our charger input voltage, if I'm not mistaken. Next we've got 0D. I shouldn't really go through all of this. Relative state of charge, 0D, and it reads out a value of whatever that value is. So put that back into 91. Now that I'm pretty sure is correct, because it was showing at 91% relative state of charge. So 91, if we go to what I say, it was 0D, relative state of charge, 0 to 100 in percent. Yeah, so I am on the right path with reading all these out. So yeah, 91% charge, and that's from me manually feeding power into the cells to get it off the ground. So at the moment, on the whole, the data seems to be looking fairly intact. Now this is interesting. Here we have it accessing battery status, which is address 16, and here are the bits it's spitting out. These are the bits and what they mean, looking at left to right, with the most significant bit 15 and the least significant bit down here, ending up in another table of information as well. So we can see bit 15 being first on the left, and if we have a look here, we've got 1100 and then 0000. So there's our 15th bit, which is a 1, so we know that it's set to battery is full and stop charging. The second bit 14 is also 1, so that's set, which is terminate charge. They go hand in hand, don't they? Makes sense. Next we look over here to the 7th bit and the 6th bit. There we go, 6th bit is a 1. So we have a look down on the table. Bit 6 says battery discharging. Well, that makes sense too. If it stopped being charged, it should be in discharge mode and being used by the laptop. Okay. And bit 4 next in line, which says fully discharged. Battery is depleted. Stop discharging. Now, though it's very contradictory, you can't have a battery that is fully charged, you can stop charging it, and then also fully depleted. That doesn't make sense, and that is most likely why the output FET on the battery itself is not turned on, and there's nothing coming out of the connector. This is also the first communication from the motherboard. When turned on, it checks the battery status. Oh boy, having a bit more of a closer look at this, bit 7 determines whether the chip has been initialized or not, which is done when it's first calibrated at the factory. And if it is cleared, which it is at the moment, it's a 0, it means that the battery electronics have determined that calibration or config info has been lost. And that would have happened because it was left to sit and go flat over a long period of time. They ran down to about a volt per cell, and so yeah, given the current configuration of them, that would leave us with ultimately it would have left us with about 2 volts on a chip that requires about 3, or was it 3.3 to run. So whap whap, maybe that's why it's not working. Well, I almost guarantee you that's why it's not working. It's got the do not use flag set, so the output FET's off, and it's got oh well, I need to find a way to reprogram this chip. Well, unfortunately my worst fears have been recognized and the battery pack is pooched. Don't let them sit around if they stop charging, otherwise they will drain themselves to a point of no return. So that's a lesson for today's little adventure. I'll have a look around, and if I can find a way to write to the chip and recalibrate it or reinitialize it, I'll do a separate video, but at this stage it's not looking too hopeful. I wouldn't know what commands to send in what order, and so on and so forth. And for $100 US you can purchase an evaluation board from Texas Instruments, which I get the feeling you could probably use to address this chip and set it up. I had a quick look at the software, which is free. Looks like it does all the good stuff like that, so not worth doing that really. There is a chance that the cells have been damaged from sitting in a discharged state for so long. The capacity of them could be diminished to the point of you may as well not bother using them, but initial load that I put on it seemed okay, although it wasn't a great load. It was about 0.5 amp I think. But yeah, that's the way the cookie crumbles. Thanks for watching, and Hopefully you might have learned something, but I sure did. We'll catch you next time.